creatures are communicating with us. So we're about to enter a little saga here, and we've heard close to 8 vocalizations. All quiet.
Thank you. Okay, let me start out just by a brief introduction. I've been interested in Sasquatch since I was a kid. My mother took my brother and I to a film that was shown at the University of Montana in Missoula quite early on. I think it was about 1969 or 70, and I wish I could remember the title of the film. I can't. I believe it included the Patterson footage, but I'm not sure. And as a child, I was immediately interested and was quite surprised that other people weren't interested. Why isn't everybody interested in this stuff? And so I followed that as a child throughout to about the mid-70s. And somewhere by about the mid or late 70s, I simply stopped hearing about Sasquatch in the mainstream media, television and magazines. And as I got older, I simply became interested in other things. And took sort of a hiatus on being interested in Sasquatch until about 2000. And in 2000, with the access to the internet, I'd seen a segment regarding the Skookum cast. I thought, well, that's pretty amazing. And with the internet, I could sort of go back in time and start catching up on all the information that I'd missed over the years about Sasquatch. And by 2000, there was an entirely new class of evidence that I'd never heard about, the class of evidence of examining dermal ridges. And I thought, well, this is really spectacular because clearly the science of fingerprinting is a mature science. It's been around for more than 100 years and well established. And I thought, wow, why isn't more information out there about this? Why isn't this being talked about at length? So I would read as much as I could about dermal ridges, look on the internet. I'd read Grover Kranz's books. And in Grover's books, he publishes a number of photographs of these features, and you probably hear me complaining about this from time to time during this presentation. Fine features on casts are difficult to photograph well. I've done my best to photograph some of these myself. I'm an amateur photographer. I think some of them are going to be okay, but that was one of my problems. I would see pictures of all this evidence, and I just couldn't exactly make it out. But there was one thing I was skeptical about, and that was, is it really possible for an impression as fine as a dermal ridge to be retained in a substrate like soil, and then is it possible for this to be cast? Is it possible to be picked up by a casting media? So at this point, I was sort of a dermal skeptic. Well, my dermal skepticism at this point was not without reason. This is a photograph of a cast of my own foot that I made in Hydrocal B11, and some of you who've actually made casts in the field will recognize that what you often get is a great deal of adhesion. The cement simply sticks to the soil, and in soil, most topsoils, not a very good medium for capturing fine detail, right? And so I reasoned that if you're going to be able to capture fine detail, that you would need a very fine medium to be able to capture fine detail. This is another shot of that same cast, and the photographs are coming out okay. You can even see little rocks that are picked up. And this is quite common in a lot of Sasquatch casts. You simply don't get a lot of surface detail. So I reasoned that, well, if you're going to get surface detail, you'll need a fine medium. I build furniture, and I've experimented with various mineral powders because I add them to epoxy to make epoxy putties, right? And so I had in my basement a large bag of fly ash. This is fly ash, and it is a mineral powder that is a product of coal burning. Apparently America produces millions of tons of this stuff. A lot of it's emptied in landfills. It's a very, very fine mineral powder. I had a bag of it in my basement because I had been mixing it with epoxy. This is a photograph of my foot in a box which I built to test whether a substrate could pick up ridges as fine as human dermal ridges. This is actually from a video that Rick Knoll took that he's trying to document some of this stuff. And you can kind of see some ridge detail right there. Those are my dermal ridges. Okay, so at this point, I was beginning to change from a dermal skeptic to a dermal believer. This is the cast that resulted from that experiment, contrasted with my own foot. And we're going to have to give you a close-up here to see what's going on. Now, this is a very telling photograph because over here, which is the heel area, you're seeing my own dermal ridges being captured. However, and this is where everything began to become kind of strange. You'll notice here a major fissure that runs throughout the cast, and very interestingly, at the ends of the fissure, you see additional ridges, and some down here, and you can hopefully see these up here. Now, if anybody in the back is thinking, well, I can't see this stuff, I don't know what you're talking about, I have decided to take the actual casts that I'm going to be talking about and putting them up at the table in the back, the Seattle Museum of the Mysteries table, for everyone to walk up at their own convenience and take a look at this stuff, because I'm of the firm belief that photographs are just not good enough to really get an understanding of what's going on here. But so at this point, this is probably late this last winter, and so I got an unusual result. I'm seeing my own ridges. They're in this cast, but then again, I'm seeing something else, and I thought, well, that's amazing. Well, I was simply curious about this, and so I decided, well, let me do a test to eliminate known texture, my own foot texture, from this equation, and so I built an impressioning tool. This is my high-tech scientific specimen. This is a piece of smooth acrylic. It's simply been epoxy glued to a 2x4, and I would put it in this box full of fly ash and simply press down on it. When it started, it was a piece of virgin plastic that's completely smooth, right? So what I'm doing is impressing a completely glass smooth surface into a compressed powder. These are more images of my foot, and I had not seen this on a big screen. You can see my own dermal ridges in the cast. They're there, and that's pretty good. I don't know if you can see it, but those are my own laterally occurring dermal ridges on the heel. Okay, so I built this impressioning tool. Here it is, and decided to press it into the fly ash. This is the first cast I made, and that's this cast. And the reason I'm showing you the back is because as a complete beginner at casting, I really didn't know what I was doing when I started out. And I'm actually showing this for a reason. If some of you people can perceive this by the photograph, you'll see around the border here that's been flattened. Well, I took an angle grinder and flattened it down just so I could get a flat surface to put this text on. Well, that's a clue, and I didn't know what it meant until a lot later on. Well, it's a simple clue, but the surface of this cast was something like the surface of frosting on a cake, and that's why I had to flatten it down. Okay. This is a cast I made much later in mud in West Seattle, and I show it only because it's a completely smooth surface. By this time, I had figured out just how much water that you had to add. Now, that is an approximately correct ratio of water to slurry, water to cement, and that's one more shot of the latter cast showing a smooth surface. Well, why is this important? Well, because I believe that the thickness of the slurry makes a difference in the final texture that your cast results in. This is going to be some photographs of the cast that I just showed you. And here we get some surprising stuff going on. Again, the mention about what you're able to see in this photograph, you're going to see a major fissure here, a major arc, and let's just call it a furrow, because that's what it is. It is a furrow. You'll also have some furrows over here. Well, why are those there? Well, those are because, as a beginner, my pouring technique was a little bit haphazard. I simply globbed it on and kind of moved the downward flow of slurry onto the substrate. And these major fissures represent a stall in the wavefront. As the slurry hits the substrate, it now starts moving laterally. And These major furrows represent where the wave front has stalled. So you get some weird haphazard shapes over here. It's again difficult to see in this photograph, but I'm going to show you some close-ups. At the ends of this major furrow and over here, you get some very interesting activity. Now, can people see this? I hope. All right. Here we have, let me go back. Here we have some ridges that were not impressed into the substrate. Remember, these are ridges that are arising spontaneously from a flat, dead flat, compacted surface. These ridges are occurring only on one side of this furrow. Now, that may seem like a trivial detail, but I believe it's relevant. It's a subtle detail, but it's relevant. All this stuff is a summation of a bunch of subtle details. And let me show some other photographs. Here's a fairly good photograph. Definite ridge activity here. And on this side, a little bit down here. And it doesn't always occur adjacent to furrows. As you can see up here, sometimes it just occurs in the flat area. More photographs. This is a pretty good one. Again, showing this feature of these ridges that often occur adjacent to a major furrow. I took this picture and it came out pretty well. Yeah. Okay. And now here's an interesting feature. It's relevant, I believe. You'll notice that at the terminal end of the furrow, it begins to branch off. It tapers off into these very fine ridges. Well, at this point, I thought, this is amazing. But even more importantly, I thought, my goodness, some of these ridges look like the cast that I saw on the DVD Legend Meets Science. As I said earlier, I'd seen these photographs that had been taken by Grover Krantz on the internet, and I couldn't hardly make sense of them. Well, the DVD Legend Meets Science was well done in terms of lighting and production, and I could easily see the ridges on that cast. At that time, I had no idea who made the cast, where it was made, what conditions it was made in, or any other information about the cast. They showed it on the screen for a few seconds. This is the cast that was on Legend Meets Science. This was a cast made in August of 1967 by John Green on Onion Mountain. This is that cast. These are photographs that either Rick Knoll or Jeff Meldrum had taken. This is fascinating. This is an image that I thought was made by Jimmy Chillcutt, but learned just yesterday was made by Jeff Meldrum, and it's really good. I sure hope everyone can see this. This is essentially what you might call a fingerprint image of that cast, and it's amazing because the cast in question, has really impressive ridges all around the periphery, and there's some on the heel, and there's some on the toes. I mean, it's really amazing. If you take one look at it, you think, well, wow, that's impressive. So at this point in my researches, I simply saw a resemblance. I had left this rectangular test cast at the Museum of the Mysteries and was telling people about what I had discovered so far. Charlotte of the Museum of the Mysteries had advised Rick Knoll about this, and one day Rick Knoll came down to take a look at it. And so I was very nervous about showing this to someone who had been in the Bigfoot world vastly longer than I have. As you know, I'm a complete neophyte. And here's a guy who is a casting expert. At first I thought that it was hype that he was referred to as a casting expert, but he really is. There is no doubt. He really knows his stuff. He really is a casting expert. So at this point I'm kind of under the gun thinking, well, you know, I'm biting off more than I can chew. This is going against the grain of the Bigfoot world. But surprisingly, he photographed the cast, and he seemed primarily interested in documenting what I was doing. He seemed fairly neutral, and it's unfair to characterize other people's opinions if they're not here, and I'm not going to try to do that. But it's fair to say that he started to document what I was doing, and he was very helpful in helping me research what's going on here. So I thought, well, okay, how relevant are these tests to the real world of Sasquatch research? Because you can't get Sasquatch to step in beds of fly ash. So I thought, well, if this has any relevance to the world of Sasquatch research, you need to demonstrate it in real-world substrates. Rick had told me about a place near Bonnie Lake, Washington that's called Clay City. It's not really a city. Apparently there was a brick manufacturing operation there. There's a bunch of bricks scattered around. And the soil is really amazing, very clay-like. I found a big elk track. So I went out there, this is late last winter, and grabbed a bunch of this soil, and I dried it out and sifted it, because by this time I had learned that the Onion Mountain cast was made in a very dry soil substance, and also I was trying to imitate the conditions of the fly ash, a very fine dry powder. Let's see, okay. Now, here we get a different kind of result. This photograph doesn't show it very well. Maybe you can see it. There's a very small ring here. Again, this is a subtle detail, but I believe it's relevant. What does that ring represent? Well, at this time, in my pouring technique, I would start at one end of the depression and pour in a sort of a straight line. This represents where the slurry first impacts the dry compacted surface. And you'll see this feature pop up again and again. You simply get a tiny ring. Now, you notice I'm doing traditional old school casting. You mix up the slurry, you pour it in the track. Some of you may know that Rick Knoll is now utilizing a different technique called splash casting, which I have not tested. I have not tested splash casting or what it will do. But most of the Sasquatch casts you see out there, made before probably the mid or late 80s, are done with this traditional technique. Mix up the slurry, pour it in the track. So that's what I'm testing. Here's a little bit of a close-up. Again, here's that tiny circle, represents a point of pour, and we see here a tiny bit of ridge detail, tiny bit. But let's be honest, there's almost no activity, right? So this is essentially a negative result. And at the time, I had no idea why it was negative, but I figured it out later, I think. Here again is, and so I, being a typical dogged amateur scientist, well, if it doesn't work first, we'll try it again until it gets to work, right? So here I made a second test, and the same central result. For those who are really interested, these cracks represent, I had put this bed of dried Clay City soil in a plastic bucket, unlike the first wooden box that you saw, and this represents a lateral force pushing the soil sideways, and these are cracks. These are actually cracks in the compacted powder. So if you're going to do any of this testing, you need to do it in a very rigid box, or your fluid bed will move laterally. This is a close-up. I think this is on the second test, or yes, a second test. And you see a teeny weeny bit of ridge artifact. Very subtle, essentially a negative effect. This is my favorite pointing tool. This is a sharpened melamine chopstick with a chisel point. And this is the ridge artifact. All right. Well, so as my investigation technique moves along, I realize, well, I don't need something this big. I can simply make impressions with smaller tools because I'm just checking for surface effects. I'm not sure this is the same cast, but now I'm getting into just making little blobs, right? As you can see, this is about the size of it. And now we're seeing some ridges again. This, I believe, is fly ash. And I think this is a photograph that Rick Knoll took. And we definitely, again, see some ridge activity. And now you're beginning to see an effect that's important. You're going to see these concentric ridges. What does that represent? That represents the flow direction of the slurry after it has made contact with the substrate and is now moving laterally. This is the first point of pour. You can't quite see it in this photograph, but there it is. I'm not a fingerprint expert. I consider that I have a layman's understanding of fingerprints. If you were going to use fingerprint terminology, I believe this would represent the core, simply because that's where all the features emanate from. Okay, this is this cast, so you can get an idea of how big it is. And now we're seeing another feature that we've seen once before, this major furrow. And the more significant ridges on one side of the furrow. There are ridges over here, but they're more subtle. Again, this is hydrocal B11. But this is a subtle but important feature, that we have a furrow that acts as a boundary for these ridges. I don't exactly know why it does it. My best guess is that the ridge artifacts emanate from the furrow rather than are terminated by it. So I thought, well, let me see if any other soils will work to produce this artifact, and I decided that this is a test that I made just recently. So at first, I'm just working in my basement. I'd contacted Rick Knoll, but I was just doing this for my own curiosity's sake. This is one that I made after I was invited to these two conferences, so I realized, well, if I'm going to be taken seriously, I better start documenting this stuff seriously. So I can see the day, the date, how I'm doing it. And this is essentially a retroactive test, but this is from soil that I took from the Duwamish River near Seattle. This is from the bank. I actually got a big virgin blob of soil from the bank rather than down by the water, and that's because it doesn't have any topsoil in it. I was of the belief that you're only going to get this in soils that don't have a lot of humus, organic material in it. And here we go. These are ridge artifacts around the periphery of this cast that we're getting on a natural soil. So now this is a proof that this can occur at least in a natural soil. It's not some artifact that just occurs in fly ash. Interestingly, these represent folds in a polyethylene sheet that I used to compact the substrate. So we can see that this Duwamish River soil is fairly plastic, and that'll be an important factor. One more view. Again, you can see ridges around the periphery. This photograph doesn't quite capture. There's a very subtle furrowed ring that represents a point of pore at the very center of the cast. That's a pretty good picture. And as you're beginning to see that these ridges are basically parallel lines, sort of a cornrow type of effect, or maybe if you drug a rake in soil, parallel furrows, parallel ridges. This is a comparison of the ridges found near the heel section of John Green's cast. Here again with the melamine chopstick. This is a much more significant furrow than the ridges that are adjacent to it. This is not a ridge, that's a furrow, and it's fairly pronounced. But you see the same kind of effect here occurring in Green's cast. You've got this furrow, and then you've got these ridges that are adjacent to it. Just so everybody knows, these are cracks that resulted because I used too much PAM in spraying in an elastomeric mold that Rick Knoll had. These fissures are not part of the cast. Those are my own lack of technique. To be honest, you've got to include results in your testing that don't come out the way you like them to. This is a test that I made later. I have no idea what these radial ridges mean or represent. They're atypical of the kind of ridges that I'm getting, but they're there, so it's honest to report it. Again, you'll see the point of impact. You'll see some of these. And so about this time, I thought, well, regardless of the reference to Sasquatch research, what is causing this? And so I tried to figure out the conditions. And so I came to the conclusion that for this effect to occur, the substrate has to be very fine, and it has to be compacted. This is a test that shows what happens when you pour UltraCal 30, another excellent casting cement, over uncompacted fly ash. And I'll show you a close-up. Well, you get nothing, right? You get no ridges artifact. This substrate has to be compacted for this to occur. I started testing out a whole bunch of substrates, and the next thing I figured out was that the substrate needs to have a strong wicking ability. It first of all needs to be porous. It's a well-established piece of information within the world of casting that if you pour cement on a non-porous surface, you will not get these artifacts. People have been casting things for years and years and years on non-porous surfaces to make figurines and all kinds of things. And so it has to be able to have a wicking effect. But there's an even more important effect that, okay, let me demonstrate something regarding the wicking effect. These are glass beads that have a really outstanding capillary action. But the capillary action is not a sufficient condition. I believe the third condition that's necessary for this is plasticity. The substrate needs to be able to hold an impression. The glass beads have excellent capillary action, wicking action, but they won't hold an impression. I hope everyone can see that. And let me compare that with fly ash. If you compress it, it'll hold an impression, right? It's plastic as a powder. If you are testing these clay-like materials, it has to be dry. The clay city soil is very plastic when it's wet, but it's not plastic when it's dry. And that's I believe, the last essential necessary condition for this to occur. This is Duwamish River soil that I'm testing. As you can see, it's quite plastic. It'll hold the impression. And this is another substrate that I've been testing, which is volcanic ash. And I got this at Seattle Pottery Supply, and I asked them, I said, wow, volcanic ash, is that from Mount St. Helens? And they said, no, it's not. It's from Hawaii. It would be interesting to test Mount St. Helens ash for if it has reference to the Pacific Northwest. But you can see it's okay. Yeah, it's quite plastic if you compress it well. This is the Zen interlude. I'm not trying to be too facetious about this. These are photographs that I took down on the beach at Alki in Seattle, and I show them only to show that this ridge-making process is not something that occurs just in my basement. I don't know why tidal flats have this kind of a surface texture, but they do sometimes. Here's another photograph. And so after I'd made an acquaintance with Rick Knoll, and he wanted to document some of this stuff, and I was beginning to find ridges, I thought, well, Rick Knoll recommended that I attend his conference to show these things to Jimmy Chillcutt. I'm kind of an impatient person, and I simply didn't want to wait the months to speak to Jimmy Chillcutt. So I made some test casts and sent them off to him. And after he received them, I spoke to him on the phone rather briefly. And my impression of the conversation was that his interpretation is the cast that I showed him didn't really change his outlook on things. So it's unfair for me to characterize what he thinks about all this. The honest answer is I don't know. I've done a number of tests since I spoke to him on the telephone, so there's new developments of what's going on. But one thing he told me that was very important was that the ridges on the test cast that I had showed him, the ridge tops were very flat, and not being a fingerprint expert, I hadn't noticed that. And he said, well, the ridges that you see in Green's Onion Mountain cast, the ridge peaks are very rounded, but the test cast that I was making were very small. So I thought, well, okay, well, maybe this is a damning notion for the suggestion that Green's cast could be a result of ridge artifacts. Rick Knoll, by this time, had allowed me to make a copy of Green's cast. He's got this female, I believe it's latex mold, which I had poured the UltraCal in to make this copy. And the moment that he handed me this cast, I was shocked because some of the ridges on the medial plantar surface of this foot, the inside of the bottom of the foot, the ridges are much bigger. They are much bigger than the small ridges that I had seen. And that's one of the problems with photography of this stuff, that if you just look at photographs, it can be deceiving as to the scale, how big are these things, right? So I caution everyone, look at the casts themselves if you can, and don't make judgments just by photographs. I feel at this time when Rick Knoll handed me this mold, I felt like I'd been studying oranges and he just handed me a grapefruit, right? So at this point in my studies, I thought, well, I've seen things that may be relevant, but there are these features that are inconsistent with what I'm showing up. And I continued to make tests and racked my brain to figure out what conditions it could be that could lead to the ridges seen on Green's cast if this was the mechanism of it. So let me take just a minute to show you a little bit of background about Green's cast. John Green heard about tracks that were found in Northern California on Blue Creek Mountain and Onion Mountain in late August of 1967. And these are photographs. Some of you may have seen some of these photographs. John Green gave some to Rick Knoll, and Rick Knoll posted some of them on the Bigfoot forums on the internet if you follow that. Some of them black and white, some of them color. As you can see, gigantic tracks. Here is a track alongside of a car tire. So you're beginning to see how fine and dry the materials were. Here's a track that was made, and there are little pine needles in it, a little bit different. And this is a great photograph. As you can see, gigantic tracks. And this appears to be a track made by some gigantic earth-moving machinery. They were building a road at that time, and this is why you get this gigantic stretch of this really ideal substrate for capturing tracks. Here you can see footprints made by some of these gentlemen, and you can see how well the substrate is capturing those impressions. So you could argue, well, the substrate is plastic just by the photograph, but you can't really judge by the photograph. It's good for holding these tracks. I think this may have been reprinted on the track of the Sasquatch. Okay, well, John Green didn't use ultracal or hydrocal. The reason I'm using those is because they're better casting materials. Ultracal and hydrocal differ in how they mix with water, but the final result as far as this casting artifact is relatively the same. And so it's unfair to judge Green's cast based on ultracal or hydrocal. So I thought, well, to test this properly, you should use plaster. At the point where I had sent Chillcutt some test casts, and I was racking my brains thinking, well, what condition could it possibly be that could lead to large, rounded ridges as artifacts? I was volunteering down at the science fiction convention some months ago at the Radisson, and I had we had a table set up that had some Sasquatch casts, and I had a couple of these small test casts there that I was showing off, and a gentleman who did casting of science fiction figurines took one look at them and very offhandedly said, well, that's what happens when you let the cement set up a little bit before you pour it. Well, that's amazing. That was an amazing thing. I had not even thought of the possibility of, what if you don't do it quite right? What happens? Well, as soon as I could, I made a couple of test casts, and this is one. This is a test cast of ultracal 30 over volcanic ash, where I had allowed the cement to set up for about 5 minutes before I poured it. Again, you have enormous ridges. And very importantly, this photograph is, I think, a tad out of focus. And what I'm trying to demonstrate here is, A, the ridges are big, but now you have very rounded ridges. So the equation is fairly simple. Small ridges, flat ridges, big ridges, round ridges. The ridges on this cast, which are small, are fairly flat. The ridges on this cast, which are big, are quite rounded. That is actually consistent with the ridges seen on Green's cast. The ridges that run the length of the cast on the inside and outside are big and rounded. The ridges near the heel area are flat and small. This is a comparison between that cast and Green's cast on the medial plantar surface. One feature that I see is that these ridges seem to run for a longer period of time before they terminate or bifurcate. Whereas here, they don't run very far before they terminate or bifurcate. There's a family resemblance, I think, but it's not an exact resemblance. This is another test cast that I made, again over, I believe, yeah, this is over fly ash, right? And here we see a very interesting feature, because you can see this little circle that represents the point of pour. By this time I'm doing tests. By this time I'm doing tests rather than using these flat impressioning tools. I was simply making impressions in the substrate with my hand. I would get the powder, I put a polyethylene sheet over it, and I would impress it with my hand. It didn't take much compression force to make these indentations, and they are somewhat more representative of Sasquatch casts because they are deeper and thicker and they're kind of round, right? They're not flat and angular like these other things, so they're possibly a little bit more representative. Here we see this point of pour in the center. It's a subtle ring. And this is a very interesting development. I had no idea this would happen, but that's the beauty of science. You find out stuff that you don't expect. There is a ring of ridges around the periphery of this cast. You can see a little bit better down here. there are no ridge artifacts in the middle. By definition, that's what a ring entails. And then I began to wonder, well, is that the only condition? If this is a result of, if greens cast is a result of ridge artifacts, is that what happened? Did he accidentally wait 5 minutes before he set it up? Well, as the more I investigated the nature of casting materials, I discovered that there's something else. This is a diagram that I made simply to avoid copyright problems. You can double check my accuracy by visiting United States Gypsum's website. This is a graph that they put on their website that represents the curing time of #1 pottery plaster, ordinary plaster of Paris. They're holding the cement temperature at 70 degrees Fahrenheit and varying the water temperature. And this is a graph of setting time versus temperature of the water that's added to the dry powder. And we see here at a maximum of 20 minutes at 60 degrees Fahrenheit down to a minimum of 16 minutes at 100 degrees Fahrenheit. Well, that's a very interesting number, because if you read on the track of the Sasquatch, you will find that the days that Green made his casts were, quote, over 100 degrees. So I believe it's possible that if in fact Green's cast is a result of casting artifacts, that it's possible that his plaster may have set up simply because it was hot. It's possible that leaving the water and the plaster out in the hot sun, that they would have gotten at 100 degrees. The non-scientific experiments I've done with plaster of Paris is one of the reasons I don't like it. It's because it can kick off in unexpected points. It's difficult to judge by eye the correct ratio of water to cement when you're just mixing it by hand, right? And it can kick off. So there are consistencies in this line of argument. Again, another test with plaster of, plaster of Paris. Yes, okay. Here we're showing that plaster of Paris can exhibit the same kinds of ridge artifacts as these other casts that I've made with hydrocal and ultracal. Plaster of Paris does this too. This is an end view, another view. And again, to be honest, you've got to mention when things don't work out as per your theory. This is plaster of Paris over fly ash. As you can see, it was made at a time when I didn't think I was going to be at a conference, so I wasn't really documenting the stuff as clearly as I could have. Notice here you get a great deal of adhesion of the fly ash to the plaster of Paris, and you can see ridges here that are nothing like the ridges that are seen on Green's cast, so a negative result. This picture I showed just to demonstrate, you do get this major furrow, so I believe that represents, again, a stall in the flow of the slurry along the substrate. This is another second test cast that I'd made with ultracal over, I believe, fly ash, again demonstrating this ring, which is the point of pour. Well, now we get into a serious analysis of Green's cast, because this is, I think, a bamboo chopstick pointing at a furrow here. It's very subtle. It's very subtle, but it's there. This is probably one of the weaker forms of evidence that I'm presenting, because, of course, this tiny furrow could represent simply the way that the substrate was compacted that day. However, you've got to get the slurry into the track. There's a couple ways to do it. You can flick it in with splash casting. That was not done here. You could theoretically dig a trench and pour it in like you're pouring pig iron, but that didn't happen. So if you're doing it by just pouring it into the track, the slurry has to hit the substrate somewhere. And this is roughly in the middle of the track. So it's not irrational to suppose that that could represent the point of pour. Why is that important? It's important because I was under the impression that the dermal ridges of Sasquatch flow lengthwise along the foot, whereas humans flow crosswise. So, and you can also see that the most prominent ridges on Green's cast are flowing lengthwise along the foot. Well, at one point I simply had the Gestalt experience where I perceived the totality of this cast. And the reality is, and you're going to see it on the slide prepared by Jeff Meldrum, which is quite good, that there's a ring. There is a ring of ridges. The ridges that run laterally turn the corner. near the big toe. They run across. They again turn a corner, run down, and they again turn a corner. They're back here. This cast exhibits a ring of ridges. By definition, a ring has nothing on the inside. There are no ridges between this center point and this ring of ridges. That is consistent with some of the test casts that I've made. This is an excellent slide demonstrating the ring of ridges. And you can see on this print, this is the feature that I'm talking about at the center of this ring of ridges. This here near the heel is the furrow about which forms a border for these ridges. You've seen that on some of the early test casts. And if you can see it on this screen, there are points on this print where you see the ridge even beginning to branch out. You see, okay, this is what appears to be a furrow, and then it begins to branch out. This is one of the better demonstrations of this effect in a larger plaster of Paris cast that I made. This is plaster of Paris against volcanic ash, and this is kind of interesting because you can see where the ridges are forming and it's beginning to pull away from the substrate. This photograph didn't come out too well, but this one did. I like to photograph some of these features against my own finger, because even if you photograph them against a ruler, it's difficult to judge the scale. Again, I harp on this. It's hard to see, it's hard to understand what you're seeing just by a photograph. So I find it useful to photograph against my finger because everyone has an understanding of how big their fingers are, and so you can judge even by this photograph. You know how big your own dermal ridges are versus these, which are enormous. One more photograph. And here's a comparison of this plaster of Paris cast versus the ridges seen on the medial plantar surface of Green's 1967 Onion Mountain cast. There's a resemblance. Again, these ridges run for a while before they bifurcate or terminate, somewhat analogously to these ridges. And here is a subtle ring in the center represents the point of pore. There it is again with the melamine chisel-pointed chopstick. This is hard to see, but there's a furrow, and there are ridges on one side of the furrow. Not a great photograph. That's a better photograph. This is a furrow. There are ridges on this side. And this is kind of a side view that I made. That's the ring that represents the point of pore. A subtle furrow, ridges on the side of the furrow. By the way, I'm seeing a face here, an eye, a nose, a mouth. So I believe that I'm going to have to forward this to Eric Beckchard for further analysis. This is a photograph of Green. I had a theory for a short period of time that this ridge artifact could have been due to a barrier spray in the track. Green and these guys experimented with trying to actually lift the tracks out. You can see how dry the substrate was. They tried to lift it out. Here's Don Abbott using hairspray. I tried to see what hairspray would do to a track, and I didn't apply enough of it, and I didn't apply it for long, let it dry long enough. And I got these enormous parallel ridges that run for a long time without bifurcation or termination. However, I learned later that Don Abbott was not even there the day that this track was made. Later on, I got a much better result. Let me save that for a minute. So to make things exciting in the Sasquatch Conference, I'm going to read a piece of email because by now some of you are thinking, well, you may have heard that Green had seen ridges in the tracks, and so I thought, well, yes, that doesn't square with the potential that these are ridge artifacts. Well, I tried to clarify that, and I got a phone call from Rick Knoll, who had just spoken to John Green. Now, unfortunately, what I'm going to tell you is a third-hand account, but since I'm trying to make this point, it's worth trying to do correctly. So I wrote an email to Rick Knoll trying to clarify some of these points. I said, Rick, thanks again for taking the time to help me. As you might imagine, I found the information in your second phone call today quite startling. So just so I understand everything perfectly clearly, let me ask you in writing. I certainly don't want to mislead anyone in the public or broadcast misinformation at a conference. I hope that in the long run, everyone will be a little bit more clear about exactly what is going on. Would you be so kind as to tell me if I'm grasping each of these points correctly? Question. John Green saw ridges in various tracks on Blue Creek Mountain and Onion Mountain. He discovered this by shining a flashlight on a track at night and illuminating the track obliquely. Answer. Some of the people he was with at the time shined a flashlight on a track, and he saw ridges running lengthwise in the track. Question 2. He photographed the track with pronounced ridges, but the photograph did not come out. This was not the track that was later cast and is now known as the Onion Mountain cast that exhibits pronounced ridges. Answer. He photographed the above-mentioned track, but it did not show the ridges. I don't know if I have seen that picture or not. He did not cast that track. 3. The cast that you have a female elastomeric mold of and from which you let me make a copy was on Onion Mountain, not Blue Creek Mountain. Correct. August of 1967. Is this Onion Mountain cast the only one made by Green in which significant ridges show up? Answer. I think so. I don't remember who cast the Hyam Palm casts. It may have been Titmus. Question. Green decided to let the experts decide about the nature of the ridges on the Onion Mountain cast and avoided a public announcement of his own interpretation. Answer. Correct. At first he thought the ridges he saw on the track indicated a wooden foot made it. Question. Neither Don Abbott nor Rene de Hinden was present when the Onion Mountain cast was made. No glue or aerosol spray was applied to the track before it was cast. Answer. Correct. So this is not, whatever it is, it's not because of an aerosol spray release compound. And the $64 question. John Green told you today, May 19, 2005, that the track from which the Onion Mountain cast was made did not exhibit ridges in the substrate before it was cast. Answer. He said that he didn't see any, but he wasn't looking for them, and he didn't have oblique lighting available. It's possible there may have been ridges in the track in which this was cast. It's possible, especially it's possible if the ridges were very fine. However, if you take John Green's statement at face value, then this, as a possible mechanism, the ridge artifact mechanism, becomes more plausible. Since I'm not a fingerprint expert, I'm trying to avoid coming across like I'm having an expert opinion. What I'm trying to do here today is simply offer evidence that there are similarities between this casting artifact mechanism and Green's cast. You have to ask yourself, well, what are the implications of this? As I said earlier, I believe that this effect is only occurring in very dry substrates. Since I'm sort of out of the loop as far as Bigfooters go, I've only been learning very recently. In fact, yesterday I spoke to Dr. Jeff Meldrum regarding some of these other casts. Some of the other casts, like the Elkins Creek in Georgia and Paul Freeman's Wrinklefoot, I'm finding out were made in wet substrates. So whatever those ridges on other casts that exhibit dermal ridges are probably not as a result of this casting artifact. I'm going to try to conclude on a positive note because you think, well, whatever happened in the past is going to be controversial, but since this is now being made public, what are we going to do about it? Well, the answer is you need to use a release or barrier compound correctly. So I showed you the failure that I made in the first place, and now I figured out, I got better examples from Rick Knoll on how to do it correctly. I had 3 applications of hairspray, let them dry about 10 minutes between each, and we get this cast, and there's no ridge artifacts whatsoever. So regardless of what may have occurred in the past, the answer is clear as to the future. If you're going to make a cast in dry powdered substrate, you need to use a barrier spray. I can vouch for hairspray because it works well. This is something I don't know enough about presently, but as you can see, 0 ridge artifacts. That's my presentation. Thank you. I'm sorry I'm running a little bit long. Yeah, I didn't plan that out well. Mr. Daniel Perez.
What is your interpretation? What is your interpretation of the Onion Mountain cast?
I believe that those ridges occurred because of a casting artifact. Yes?
You were saying that you can't really use Sasquatch luck and fly ash. If you were to spread something around the base of the tree to help capture some prints, what would you do? What would you use?
Mud is excellent.
Like, what kind of,
Well, I would probably use something like fly ash. It's cheap. You can get it 80-pound bags of it for about $6. What I'm also interested in is how dry powdered substrates clump. This is not my interpretation is not relevant as to what made the track. I don't know if it was made by an animal or a piece of wood or whatever. I don't think these investigations have a bearing on what made the track. But what I believe is a fruitful source of further research is to what happens when multiple impressions are made in dry powdered substrates, because I believe it's possible that there are no features in Green's Onion Mountain cast because of clumping. Yes?
I went to the International Institute of Hand Analysis, and I learned how to read our fingerprints, how to analyze them. I can tell people what their greatest talents and challenges are. So I am very fascinated with the lines, because we have lines in our hands and we have prints on our fingers. So it would be wonderful someday to have a handprint with fingerprints on it, on the Sasquatch.
I agree.
Yes.
Mr. Steenberg.
Yes. When you were looking at the Onion Mountain casting, are you sure that those ridges wasn't the result of the copying process rather than the actual casting of the original track?
That's a very valid question. You might ask Dr. Jeff Meldrum about the history of it, which is a valid concern. I believe that the cast was given to Grover Krantz, and I believe that Mr. Meldrum made a copy from that cast. So I'm a little bit unclear about the history of it, but my understanding was that Krantz was using a very good copying technique using latex material. So as much as I personally know about the history of this cast, it was the copies were made well.
Okay, so you don't, in your opinion, it was a result of the original casting, not the copying process?
That's my understanding. Yes?
Just a couple of points. Matt's being far too tentative.
Cast with me in closed door section. Maybe later on. The footprint I took that shows broken bones and things and toes. It's so interesting because it shows.
Is for there will always be a degree of question about, well, how did those ridges get there on Green's cast? Well, it just goes to show you how important photography is. I highly recommend for any track that's going to be cast, photograph it well. I'm an amateur photographer, but even as an amateur, I'm able to capture some of these fine features. So it is doable for even an amateur. And I would recommend for everyone to learn how to cast tracks well. I'm personally interested in learning how to do splash casting from Mr. Knoll because my understanding is that it's significantly superior. To give you a significantly helpful answer, I'm not a casting expert. I would refer you perhaps to Mr. Meldrum, who's made really outstanding casts, and I would recommend everyone to take a close look at the casts that Dr. Meldrum has made. They're very, very good. They are preserving very good detail, and as far as casting in the field, Rick Knoll is a casting expert, so I would refer to people who know more than I do about making casts in the field. Thank you.
Bye.